Welcome back to NSMA, and we're starting back in with a lot of our internal guideline development working group 3 work, and we're pleased to have our working group 3 chairman, David Meyer. David's a senior manager at Comsearch, where he directs the frequency protection and wind energy telecommunications services. He oversees the protection of thousands of microwave paths, earth stations, and other facilities through the coordination process. And he's been working in the telecommunications industry for more than 38 years. He's been active at NSMA in a majority of that time on various working groups and has been a member of the board of directors since 2005. He's also a past president of NSMA. David holds a bachelor's degree in business administration from Strayer University and a master's of business administration from the University of Maryland. Additional undergraduate studies include chemical engineering at New Mexico State, satellite engineering at George Washington University, and international marketing at Strayer. We're very pleased to have David. Come on aboard, Dave. Thanks.
Like the first time I've been to a stage, and it's a little rocky, but I don't know whether to tell Joe thank you for driving away half the audience or not, but well, at least we have an audience of enthusiasts. So, as the working group 3 chairman, one of the things that we do is we look at the coordination process, specifically focused primarily on the Part 101 licensed microwave. And the picture up here, the map of the United States, these are the 6.1, 6.7, 7 gig, 10 and 11 gigahertz, 18 and 23 gigahertz paths that are licensed point-to-point paths in the United States. And you can see there's coverage all over the place. Now, obviously, as you drill in, as most of you are probably familiar with Google Maps, you drill in, obviously, you're going to find spaces in between, but it gives you conceptually how the country is covered by licensed fixed wireless microwave. And as has been pointed out a couple of times, there's some obvious corridors you can see. There's a corridor running between New York and Chicago, and also from New York, I believe, up to Montreal. That was the high-frequency traders who decided they needed hundreds of paths all going the same place, and the reason that line is so dark is every company was trying to get the shortest path they could between the two locations so they would have the least lag time and make those trades, in milliseconds. So it does interesting things, what you can see from a map. All right, so I'm sure this is user error. I can do a page down. Okay. So what is the purpose of Working Group 3? It's a working group of the National Spectrum Managers Association. And I'm going to go through the purpose, just some very light Part 101 basics. The FCC rule part that primarily regulates the point-to-point microwave systems. Where do the NSMA recommendations fit in the coordination requirements of the FCC? Who are the participants or the stakeholders in the coordination process and NSMA? We're gonna do a little bit of looking at a bucking case, and I'll explain exactly what that is. There are some interesting examples out there when you start digging into actually what's licensed in some of the areas. We're going to look at a certain mountaintop that is a little busier than it seems. And then I'll discuss briefly a current and future focus of the working group. So what is the purpose of Working Group 3? We're set up to provide an industry forum for spectrum discussions. Anything that happens at the commission, regardless of what band it's in, what service it's in, are prime feed points, if you will, into Working Group 3. We discuss it openly. We talk about, what's the impact on the Part 101, Part 74 licensees. Do we need to develop anything to address it? We try to develop industry consensus on spectrum issues. In a lot of places that is difficult to do. In a lot of different arenas, consensus is almost impossible to do. But over the years that I've been involved in the history of NSMA, I think we're very good at developing that consensus by bringing the interested parties together and let them honestly and openly discussing the issues. We develop specific coordination procedures. The FCC, their coordination rules are very basic, and there's a lot of holes that needed to be filled. NSMA, and specifically Working Group 3, tries to fill those holes. We create recommendations for industry guidance. If you look on our website, www.nsma.org, you can look at the recommendations section and see what we've already done in the past and kind of get an idea on why they're necessary when you look at the FCC coordination rules. We're also responsible for maintaining, updating, and archiving the existing recommendations. Amazingly, we have recommendations in there from the 80s and 90s that, because of the procedures involved, remain valid, amazingly. But we are working through and continually updating those as needed. We help interpret FCC rules. It's well and good for the commission to lay out, do ABC, but if you don't understand the ramifications and the coordination process, sometimes it needs an additional explanation for that. We provide feedback and content for NSMA regulatory filings. The NSMA, if there's an issue, a band, or a docket that comes out that the membership has interest in filing comments on, then the Working Group 3 helps provide support for that. And then we also have the ability to refer actions to the board to activate additional working groups. When we went through, for instance, in the mid-90s, the PCS era, if you will, there were at one time probably 15 or even 20 working groups active in NSMA because of all the different facets involved. And we still have that capability if issues do come up that are broader than just Working Group 3. So from a Part 101 basic, the FCC, they pretty much tell you in these licensed bands, you notify the potentially affected parties, you give them 30 days to look at it, you try and resolve the problems. Sounds pretty simple. If any of you have been any relationships at all, you can find how this could get difficult very quickly, especially if the relationship is with a competitor, somebody that made you mad 2 months ago or whatever. So it can get complicated, even as simple as it is. So who do you coordinate with? The commission kind of said it's affected licensees. Well, somebody that is in 3 states away that is in that same band, they may consider themselves affected because you're doing something in a band they have something in. So the NSMA and Working Group 3 said we need to really define that. So what we did was we set up, for 2 point-to-point microwave paths, you need to look at a certain circle. And this is kind of a keyhole. If you look at the keyhole, that's the main beam of the antennas. And anybody that falls in this area, you need to send a notice to if they have a license or a proposed path in the same band. And that's pretty much it. But without this definition, how you would define that would have been left up with every person coordinating. So it would have been easy to create issues, especially when they're filing. And I want to back up just a little bit. Joe has mentioned that the FCC asked for the NSMA to be created for one reason. They were getting dragged into court. The FCC was dragged into court over and over by the big carriers at the time because they didn't have this coordination process. So they were filing licenses right on top of each other, asking for the same channels in the same places, and their only avenue was legal. So the commission said, we're going to let the NSMA and let industry deal with this. So what NSMA has done since then is try and create coordination procedures to avoid legal issues that the commission dealt with at the time. And I think we've been very successful at that. When you consider the number of filings that are now being made in these point-to-point microwave bands, and I mean, if you look at back in the Clearwire days when they were going, they were coordinating and filing for hundreds of these paths every month. And when they went through the coordination process, they were able to do that with clean coordinations without issues and problems. And that's really what the commission was looking for. So how quickly can a licensee operate a point-to-point microwave pass? I mentioned the 30 days before for coordination. That can be sped up. Somebody can ask for an expedited response. These are going to be posted, the slides. I realize this color was kind of a dark choice in the background. But essentially, if you meet the conditions for a conditional authorization in these bands, as soon as your application hits the commission and you apply for it, you can already have your equipment in, your antennas in, everything in. You can turn that sucker up. And so if you meet the conditions, you're fine. Now, if you're if you don't meet these conditions, and again, there's no waivers, no environmental impact. There's a distance restriction for international borders. There's 10 and 18 who have restricted areas. You've got to be above 15 gigahertz in Puerto Rico. And if you're in 23 gigahertz, only in a non-restricted channel. If you meet those conditions, like I said, as soon as you file for something, you can turn the system up. So it can be very short time from, desiring to have a microwave path and getting it in. And if you don't meet these conditions, then you have to wait until your license is actually granted to the FCC. Now, amazingly, unlike other services, a common carrier filing, which, if you're looking at the common carrier companies, they have a 30-day public notice period. But if you're a private microwave licensee, say a railroad or a state and local government that's going for one of these paths, then you're granted as soon as the commission has time to process your application at times. And that period has been just a few days to, a couple weeks. So even if you do have to wait to be granted, it can be a very short term or short process. This is just for reference. What I did was I took the NSMA recommendation and the FCC rules, coordination rules, 101.103, D, 1 and 2, and each of the parts of the recommendations that are currently on the website, the NSMA website, are tied in with the commission. So these are what we had to expand on from what the commission provided. Now, a lot of times you get too much information from the government. In these cases, they didn't provide enough, so that's kind of the role that we're filling. So who are the participants or the stakeholders in Working Group 3 and in NSMA? Since we provide an open industry forum and we look at issues impacting the spectrum industry and we allow a full discussion, we don't hold anybody back or tell them they don't have a good idea. We'll certainly discuss it. But our current members include coordinators, spectrum managers, manufacturers, service providers, vendors, broadcasters, consultants, licensees, academics, government, and retirees. So we have decades of experience that are involved in our discussions, and they provide a lot of insight into spectrum issues and how we need to handle them for the community as a whole. So we're going to look at a bucking case. Now, just a little bit of definition for a point-to-point microwave system, what a bucking case is. If you have two microwave paths, okay, and the transmitter and of one side and the transmitter of the other are operating in the same half of the band. Most of the bands that we deal with in point-to-point microwave are split in two. So you have a high and a low half of the band. If you have a high transmitter and a high receiver located within a close distance, that's considered a buck. You try and avoid those, but as we've seen with frequency congestion, a lot of the kind of the progression on a site development, if you have a large tower or a couple of towers close together, is everybody goes in initially and they match the plan. There's, no bucks. Everybody tries to be good neighbors. Essentially, they're using the antenna discrimination to reuse frequencies, and they try and, but when something gets completely full, the entire high side of the plan, for instance, is using a certain site, then they start introducing bucks. It's like a development timeline or progress. And so each buck then has to be looked at to make sure it doesn't create a problem. Now, the issue from an interference standpoint is if you have a 3 or 4 paths coming out of the single site and they match, then essentially their receiver receiving the other half of the frequency plan is some distance away. If you locate those very closely together, then you essentially have signals coming out of one transmitter that very possibly could conflict with what's receiving and the one that's right next door to it. And if you don't know exactly where those are in relation to each other, then any computer calculations you do have a very real issue of being off. And the other issue that occurs, if they are very close together, then they can be within the near field of the transmit and receive antennas. And when that occurs, then what is happening is the computer results are not giving you valid numbers because the antenna pattern is not fully developed. It has to get into that far field region before it's going to correspond to whatever numbers you're using. So it can create issues. And I randomly selected a site that I knew there was activity at. If you'll notice, there is I'll probably turn something off, but there's a little dot here. This is Jump Off Joe, Washington. All right, it's at the bottom part of the state of Washington, just above the Oregon line. There's Idaho there. There's not a lot of population around it, other than there is a town, I take that back. On this particular site, there is a town about right here. But the reason I chose this is Jump Off Joe is a very high ridge or mountain in an area that needs that for microwave transmission. So this is what the site looks like. There are in excess, I believe there are either 17 or 18 tower locations. Each of these is a different tower. And they have microwave on them. They may have TV. They may have radio, depending on what they're doing. But it's a massive site. So when you look at it, every one of those has a potential for potential bucking problems if they try to locate the same band. So when something's coordinated, you have to take a very careful look at it. This is what it looks. This is the point-to-point microwave paths that come out of that site. Okay, I believe there's over 84 of them. All right. And they're just spreading out all over. There are various bands. Not all of them are bucks or conflicts, but you can see it's a very busy. Okay. So this is a recommendation NSMA has on bucking sites, and which would be in place for this one, pretty much anyone, because of the number of sites that are there. But on the bottom line, I'm not going to read through the whole thing, and you can certainly look at this online. But the bottom line is try and avoid them. Okay. If you can't avoid them, all right, then try and stay in the far field. Because at least if you're in the far field of the antenna, then you can come back with accurate calculations and make a judgment as far as the interference impact. And then it also goes into, well, if you can't get into the far field because the more and more congested, somebody obviously is going to try to coordinate it, then you need to work with the other party. You may need to do some pre-service testing, some monitoring. It's going to be much more involved to put it in. It's not saying you can't do it. But the distance is involved, and again, there's a couple pages of this, but again, I'm not going to go through it. I wanted to point out that this is just a very just to give you an idea on what those near field distances are. If you have a bucking situation at 18 gigahertz with 8-foot antennas, it's 741 meters. Okay, so it's not small. I believe this goes from that high down to a low. If you look at a 3-foot antenna at 6 gig, it's 34.5 meters. It kind of just gives you an idea on how far, if you're going to buck a point-to-point microwave, meaning you're in the same band, transmit and receiver should be separated by greater than this distance. So just for grins, I took a look at, let's drill in a little bit and see where those paths are when you look at Jump Off Joe. It's the same site. But what I did is I plotted the paths. Okay, this is all FCC data. And technically, from the FCC, you're supposed to be within 1 second or 100 feet. I think it depends exactly where you're at. But you'll notice there's groups of these that aren't on any of these towers. So when somebody sends out a coordination or even makes a filing, it's going to make it very difficult for the coordinators to look at this and say, oh, that's not a problem. That's in the far field. Which tower do you put that path on? Or the one up here, they're just off. And, as coordinators, and we've had this discussion at the NSMA before, we don't regulate anything. We can't force anybody. We can recommend that our clients, if something is off, that they re-coordinate or position it. But not all of them either have the money or are able to take the time to do it. So this is kind of and this is, like I said, if you pulled ULS up and plotted this stuff in an area of Jump Off Joe, Washington, this is what you're going to see. So that kind of lends to the fact that not all the data, surprisingly, in ULS is accurate. And, sometimes solely depending on that data, you're going to miss it. You're going to miss something. So that's why when you get into a bucking situation, a lot of times what happens is it's the two parties are going to work together. They're either going to do pre-service testing, they're going to monitor, because, other that, or you can ask for, can you give more precise information? What are your exact coordinates? Can you identify the tower? You may have to go through some more steps to get it there. And to top it all off, Joe mentioned I'd work on, primarily in frequency protection, but I also work on wind energy analysis. These are all turbines. Amazingly, they like high ridges too. So if the paths themselves were not an issue, they're now putting wind turbines all around Jump Off Joe. So just to add a little bit of complication. And we consider that the wind turbines now, the typical wind turbine is higher than 650 feet tall. And the blade diameter, they're putting them in now that are 165 meters wide, the circle. So that's the kind of size that you're talking about on wind turbines. And wind turbines and microwave paths do not play well together when they go through the same airspace. Okay. All right. So this is another mountaintop. This is West Mountain, Utah. And this one is not near any major towns. It's, if you want to picture it on a map, it's about 95 miles northeast of Las Vegas. It's 185 miles northwest of Flagstaff, Arizona. And it's about 245 miles southeast of Provo, Utah. So it's right down, you can see, here's the Arizona border, here's the Nevada border, and this is Utah. So the mountain is down in the very bottom. Nobody around, no towns, nothing. What it does have, though, is towers are a little bit hard to pick out, but it has I think there's 7 or 8 tower facilities here, similar to Jump Off Joe, just a little smaller. This is what it looks like when you look at the microwave paths. again, it's very busy. It is in the middle of nowhere, okay? But it's a natural high point in the area, and it's used by a lot of different companies. So I did a little bit of drill down just to give you an idea what kind of paths are up there. What are they doing? There's 82 licensed or proposed point-to-point microwave paths within 1 mile of the center of that west mountain. 82 paths. 32 of them are in the lower 6 gig band, the 6.1 gigahertz band. So you have 32 paths, and I guarantee there's at least a handful or more that are bucks, okay, that are 6.1. We have 14 paths in the 6.6. The other thing I want to mention is path links. There's an interesting corollary when we get to the end here. The 6.1 gigahertz paths average from 15.1 to 99.6 miles. Now, normally a path link, and I'm probably preaching to the choir, most of you have heard this, are going to be dependent primarily on the band. But a lot of times it's also on the specific use they're doing. Sometimes if you don't need a high quality path, you can stretch those links a little bit. But the path links for the 6.1 gig were 15.4 to 99.6 miles. Of the 14 paths in the 6.7 gigahertz band, 15.5 to 62.2 miles. There's 12 paths in the 7 gigahertz band, 18.3 to 99.6. So there's not a huge difference in those three bands because they're very close together. We have 21 paths at 11 gigahertz, 11.1 to 47.9 miles. You can see the maximum distance shortens quite a bit at 11 gigahertz. And there's 3 paths that are just in 3 other bands, and they were 17.8 to 99.6. What's interesting about the 99.6 number in those 3 bands is all of them, all those paths, and I think there were 7 or 8 of them, are going to the same endpoint. They're all going to another mountain in Utah called Frisco Peak. So, it just kind of tells you that geography plays a huge, has a huge impact on the point-to-point microwave systems, as well as everything else, regulatory, coordination, etc. The other thing that was interesting is the last, since everything is prior coordinated in these bands, you can take a very quick look. It's not looking at the licensing and it probably doesn't go back to how far some of these are licensed, but the last new or major change PCNs at this site on those 82 licensed paths or proposed range from 1996 for the last changes on the path to 2023, just last year. So, they go, some of the paths they put in, and as long as they're consistently doing what they're supposed to be doing, they don't touch them. They use them heavily, but they don't necessarily, they're not looking for huge throughput, 4096 digital modulation. They just need a steady path between point A and point B, and this gets them there. A little bit look at the licensees. From listening to Preston Marshall and Tom yesterday morning, they got in this argument about, I wouldn't say, faux argument, I guess you would say, about the difference having exclusive spectrum or unlicensed spectrum. Well, the one thing about the point-to-point microwave system is it's open to any company, state or local government that wants to put in a path. It's not restricted by, who they are, what they do. They can put it, as long as they're not federal government, okay, who has their own spectrum, anybody can do it. So just as those 82 paths, there were 21 different licensees. If you look at the list, you'll see major carriers, AT&T, you'll see Verizon, you'll see power companies, you'll see TV stations, the variety of state and local government, all on this site. But it just gives you an idea that there's no restriction on any of those types of licensees. It's freedom that, if you can coordinate it, you can put it in. And the radio type services even tell you that. There's common carrier, microwave for industry and business, microwave of public safety, and then there's TV operators. And in fact, I think half of those, excuse me, give me a sec. Half of those 96-mile paths were with the TV people because they're connecting two major sites for them. So that kind of gives you the mountaintop experience. And then finally, the one thing I wanted to end with is what are we doing now, right now? The current and future focus for Working Group 3. We've got a couple of recommendations, one from 94, one from 91, that have to do with automatic power control radios. The recommendations and information has been good up to this point, but adaptive modulation has exploded across the bands. So some of the issues involved with that we're having to take a look at because the receive levels are getting very close to the threshold levels in some of those, and we need to reconsider what that framework is that we've got right now. So we're going to be looking at those recommendations over the next few months. We've got a new recommendation on temporary earth station process. You would think by now that the temporary earth station operators would know how to coordinate and put in systems and be a good neighbor. But here we are years after they've started doing it, we found holes in it where people are not following recommendations, are not, in our opinion, following the rules. So we're going to come up with a new recommendation to address that and hopefully help fix some of the issues we're having. There's a recommendation from 1991 on short path distance calculations. You can imagine how the technology has changed since 1991 on determining coordinates and how to translate that into providing solid information for the coordinators. And then we're going to move on. There's other coordination procedures we're looking at. There are other working group information, electronic PCNs, OH loss, RF test methods, and interference objectives that we're going to look at as pretty much a routine basis. We're going to go for everything on the site, and then we'll move on to the other working groups after that. So that in a nutshell is Working Group 3, kind of a broad view, and I'll open it to any questions. No, they're grabbing a mic, so.
Okay, you piqued my interest on the docking stations. The other frequency bands that you have to be talking about 18 and 23 gigahertz, right? The three other, you talking about the other bands that we use, some of those going out to 99 miles. I was just curious.
One of them was 2.4 gig, the TV band. I would have to double check. I think the other one was 18, one was 23.
Okay, 99 miles. Availability is.
Well, it's also, it's out west, it's a dry atmosphere, you have all the perfect conditions, but very true. Yes, sir.
So you didn't mention about Wi-Fi. Just Wi-Fi also be able to transmit the 60 gigahertz for links and power. And there's AFC, but is there any other mechanism by which you inform it?
So I manage the protection group at Comsearch, and we've got concerns because when the FCC set up the AFC process, one of the things that was not contained in there was sharing of data. The AFC operators do not have to share with each other, and there's no requirement to share with the public. I don't think there's even a requirement for them to share with the FCC. I guess they would have to if they asked, but so there's no a process in place for them to share the data. And as most of us would know, having an engineering background or being engineers, without data, you'll have to make a guesses essentially. They can be educated guesses, but they may not be very accurate. But what they did require, which they've just done in the last couple months, is for each of the AFC operators that were approved, and there were 7 initially approved that have gone through the testing process and been approved, and I believe at least 1 or 2 is fully operational now. They did have to come up with a process to handle complaints from incumbents. I believe, at least the one process I saw, they pretty much are saying you need to report it to the FCC Enforcement Bureau. You know, unfortunately, they've kind of set the FCC set the framework where that's what it's set up to do. So that's kind of outside the realm of anything Working Group 3 or you know, protection agent for incumbent would be able to handle. Any other questions? Well, I don't know how we're doing on time, but
I think
I don't-
I think we have about 5 minutes, so I think it's a pretty good buffer. So,
okay. All right, thank you very much.
thank you, David.